Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Let me introduce myself. My name is Reiyan Indra from Electrical Engineering, batch 2021. In this presentation, I would like to explain my experiment results of the Embedded System 1 course final project that is called Eco-Friendly Automatic Temperature and Humidity Control with Humidifier. We know that the warmth of Indonesia may causes the warmer temperatures or room temperatures that resulting in the experiencing a sweaty and uncomfortable feeling when the temperature rises above the normal conditions of 25 degrees Celsius. Thus, the rooms that are typically are places of rest for residents, making them uncomfortable to be in their resting places. Uh, Unfortunately, the situation can be exacerbated in areas that are remote but have extremely hot temperatures or conditions. So here is our expected solution. So as we know that the air conditioner takes up large consumption of electricity. So I offered that the humidifier is one of the best solutions to overcome this problem for those who cannot afford themselves an air conditioner due to its expensive electricity bills. Humidifiers has their own unique identity which only consume less power electricity and capable of regulating itself while in high cold temperatures. Okay, so here is the objectives of the experiment. The first thing is to ensure that the humidity sensor is able to accurately measure the environmental humidity, and Arduino Uno controls are able to respond promptly when the humidity exceeds the threshold of 80%. And the next one is to test the humidifier settings to maintain humidity at an optimal level under environmental conditions. And the last thing is to create a humidifier to be more cost efficient in its use so that the humidifier cannot be used continuously. And I would like to explain the problem measurement concept. And the first thing is when the humidity is less than 80%, the humidifier will remain on. But when the humidity exceeds 80%, the humidifier will stop, will turn on again when the humidity reaches 75%. So the next part, we would like to focus on the circuit design. So the first thing that we would like to do is to connect the 5, 5 volts power supplies from the Arduino to the breadboard. Uh, the first thing that we would like to do is to connect them for the LCD I2C relay module and the HT11 sensor. Uh, and the data of the HT11 sensor is connected to the analog input of Arduino, which is placed on the A0. And also, we would like to connect the relay, the input of relay module on the digital PWM on the second inputs. And the last thing, the interconnection of the I2C for the parts of SCL and SDA is to connect it to the analog input of A4 and A5. Also, this is the supposing that it is a humidifier that is connected to the relay module. And also this is a power supply that generates the uh, humidifier. And it is the DC power that also used to generate electricity to the MD102 power supply. Next. So in this video, this is my implementation of our experiment. The first thing that we would like to do, and we had to know that this experiment is occurred in the daytime, which is at 12 p.m. And we can see that the temperature is quite hot, which is 30.80 degrees Celsius. And we can see that the initial humidity is about 69%. So we can play it and we could see that the humidifier is on. Okay, so as the humidifier is on, the humidity is increased and the temperature is gradually decreased. So we can wait until the humidity exceeds the 80%. Okay, we can make it fasten the video until the humidity reaches the 80%. Okay, so finally it reached the 79%, and finally the humidifier will immediately off. Okay, then we can continue to this part. In this part, the humidifier cannot able to turn on since the humidity would like to decrease for a little minute until the humidity reaches the 75%. Yeah, we can see that the humidifier is still off and the humidity decreased to 75%. Look, okay, we can go faster the video. And you can show my hands is turning on the humidifier, but then the humidifier cannot able to be turned on since the humidity is still 76%. But finally, when the humidity reaches the 75%, uh, the relay module switches their mode from off to on version. And finally, I am able to turn on the humidifier. Next. So here it is, the program algorithm. And the first thing that we should do is to include the library of the wire.h. And these two components are one of the most essential part that is used to display the results of the temperature and humidity, and also the ht.h that is important parts to detect the values of temperature and the humidity rate. And we also have to set the LCD want to see address in dimensions. And the next part, we would like to define the HT pin A0, the HT11, and also we would like to initializing the pin number of the HT11. And also in the next part, we would like to track the state of the humidifier that is implemented in the last part of the program. Okay, we will continue the setup version, and this function is used to initialize the, especially for the HT and the LCD. We can conclude that the serial print and the HT11 temperature sensor are read in the serial monitor, as well as uh, this LCD print humidity and temperature controller. Okay, the next part is we would like to see that the loop of the program, which is repeated in the same schematics. So we would like to that the delay of 500 milliseconds before executing the next line of the codes. So which is the, if we want to continue on the next rate of temperature and humidity, it will delay for about 5 seconds. And we can see that the LCD prints the value of temperature and the humidity. Okay, so we will like continue to the last part. This is the consequences of the humidifier. While when it is the humidifier exceeds the 80%, the humidifier will turn low, while the humidifier is gradually decreased based on the humidity rate. Then the humidity will return to on again on the 75%. So here is our algorithm, our flow chart. So the first thing that the HD sensors read the temperature and processing input data from the Arduino Uno, and the sensor data displayed in the LCD. And when it is humidity rate greater than 80, the relay module exchanges from on to off mode, and the humidifier will off. If the humidity remain to 80%, then or greater than 80%, the humidity rate will uh, gradually decrease to 75%, and we can call it as cooling down process. Then the relay module switches off to on while it is achieved 75%, then the humidifier will able to turn on again. The next part, we would like to explain the temperature and humidity analysis. To analyze them, we would like to use the Microsoft Excel data streamer instead of serial data in the Arduino IDE. We could see that this part is the current data that may resulted in the after reading from the HT11 sensor. We could see that this is the current data, and in below we we'd like to show the data that has been taken for amount of time, and we would like to see that this is the current time, and this part is about the temperature, and the right part is the rate of humidity. Okay, so here is the results of the temperature versus the humidity. We can see that the temperature is actually increased slowly and goes constant from initial point of the time until the end of the time. But while the humidity rate goes up when the humidifier is on, then when the humidifier is off, the humidity rate will decrease slowly again. So this is the conditions of the temperature and humidity rate along the humidifier condition when it is on or off. We can see that the time interval for the initial version is makes up for 6 minutes, and the initial humidity is 68% until 79. Then the humidity condition is on based on the previous video. And the second one is the process of the cooling down, which makes up only 2 minutes, that the humidity rate should gets down from 80% to 76%. And we could see that the temperature is gradually slightly increased from 28.5 degrees to 29.3. And finally, it is the condition where the humidifier is able to turn on. We could see that the temperature is 29.3, and this is something that the temperature is quite constant, but this is assumed that the temperatures may be higher again, maybe lower again due to the on condition of the humidifier. Here are the conclusions of our experiments. So the first one, that the ultrasonic humidifiers can quickly reduce the room temperature as well as producing a lot of water vapor, thereby freshening the room's atmosphere. And the second one, the implementation of this project design. This prototype is appropriate for the applicability to low-income individuals who cannot afford themselves an air conditioner, or any other cooling systems that may look expensive for them. And the third one, this project design saves the cost of electrical consumption due to its non-continuous use. When it is temporarily off, the room temperature is still cold, where it is the condition while the humidity is still 80%, and the humidifier will immediately stop for a while, then the condition is still cold. Okay, so the last one, we also emphasize that the Arduino Uno plays a significant role in the manufacture of this tool. One of them is able to produce an energy efficient tool. Okay, thank you for watching my presentation. Assalamualaikum warahmatullahi wabarakatuh.